multiplication and division. So something like a quadratic is still algebraic because even though you have like a square is really just multiplication, right? So like exponents are really just multiplication, and addition, subtraction, multiplication, division. But transcendental functions are something we use to lump into this group of functions that go beyond that. So the ones that we're going to see are trig functions, exponential functions, logarithmic functions. So a lot of times what we'll do is we'll learn how to take a derivative with just regular old, polynomials, 3x squared minus 4x plus 2. And then we got to go back and learn how to do it again with trig, exponentials, and logs. Some textbooks don't do anything with trig, exponential, logs until you have learned everything about calculus, because technically there is to be able to prove any of that, you have to know all of calculus before you can do it. This textbook teaches it early on so that you do it all the way through. I've taught it both ways. I like this so much better because if you're not doing the rules for especially the logs and exponentials all the way through, you don't practice it enough to remember what they are. Today we are just going to talk about sine and cosine, or functions that could be broken down to sine and cosine, because the other ones, tangent, cosecant, secant, and cotangent, we have to know another rule before we can learn those. So they're going to come later. I think the last section, 210, is the one where we'll do those. So really we're only worried about sine and cosine. And these two things right here, you absolutely must have memorized well. The derivative of sine is cosine. The derivative of cosine is negative sine. You must have those memorized well. We will use them over and over and over and over again in lots of different sections that we go through. So you have to know this well. But once you do know it, some of these are so super simple. As long as you have this memorized, to do example 1, I need to take the derivative of 2 cosine x. So that is 2 times cosine x. 2 is just a scalar multiple. It's just a number multiplied. And the properties of derivatives tell us if we have a number out front, that we just leave that number there and then take the derivative of the other stuff beside of it. So for this, f prime of x is going to be 2 times the derivative of cosine, which is negative sine. Make sure you put some parentheses there so you don't think it's 2 minus sine x. It's 2 times negative sine x. Or you can just skip to writing the answer, which would be negative 2 sine x. Okay, number 2, we're taking the derivative of sine x over 2. This time I'm dividing by 2 instead of multiplying by 2. Is there a way I could write this so it would be multiplication instead of division?
Take it out in front.
Okay, what would I take out front?
2 over 1.
1 over 2. 1 over 2 times sine x, right? This would be the same, because if I multiply it back together, I'd have to, sine x is over 1, I'd multiply, I'd get sine x over 2, right? So whenever you have a number that's divided by, there's not like a special rule for that division, but you can rewrite it so that it is just a scalar multiple there instead, and it will be a fraction for that. So if I'm taking the derivative of this, 1/2 is just a scalar multiple. It just stays out front. I take the derivative of sine, which is cosine x for this. You might see that written back as cosine x over 2. You might see it written that way. Either one is fine. We are right there. Okay. Example 3 is just sort of a mixture. You have 2x, and then you've got sine x. So when we take the derivative of this, we're going to just take the derivative of 2x using the power rule. Jeremy, what do I get when I take the derivative of 2x? Just 2, right? Derivative of sine is cosine, so I've just got 2 minus cosine x. There's my derivative. So it is essential that you have those memorized, but for this type of problem, it's pretty basic on what you've got to do for that once you have it memorized. Okay, let's talk about exponentials. So derivative of a to the x. A here could be any number, any real number here for a. So if I take the derivative of a to the x, I will get a to the x times the natural log of a, whatever the base is there. So if I'm taking the derivative of 3 to the x, that is going to be my derivative dy dx, or you could call it y prime. Either one is fine. Here you have the derivative really is just itself, but then you must multiply it by the natural log of 3. Natural log of 3 is a number that you could type into your calculator, so it's going to be a decimal. You can just, so it's really just that number times 3 to the x power. Okay, if we have something like number 5, this 5 that's multiplied out front, it is a scalar multiple. So when I take the derivative, that 5 just kind of hangs out front. I'm going to multiply the derivative of the 1.2 to the x power is going to be 1.2 to the x power, but then I must multiply it by natural log of 1.2. You'll probably see them write it like this, 5 natural log of 1.2 times 1.2 to the x power. Maybe. There's not really like a perfect standard way. Okay, now you're not going to see this very often. It is in our curriculum. I have seen these put on the exam, but if you do see it on the exam, it's probably only going to be there once. What you're going to see a lot more of is the derivative of e to the x. And the derivative of e to the x is very interesting, and I had a video on this one time that we might go back and watch sometime, but we're not going to do it right now. The exponential e to the x, the exponential function e to the x, is a remarkable function because it is one of the few things, maybe the only thing, that is its own derivative. So the slope of e to the x at any point is e to the x. So it is its own derivative. The reason that the other rule still applies, so that other rule, derivative of a to the x equals a to the x natural log of a. Well, if I try to do the derivative of e to the x using the other rule, then e to the x is e to the x times the natural log of e. But what is natural log of e? It is equal to 1. Let's think about why natural log of e equals 1. If I've got natural log of e equals x, right? And I want to get rid of the natural log, I would do e to the power, right? And if I've got e equals e to the x power, what's the only number x could be that would make this true? 1, right? Calculus Facebook group saw this the other day. Somebody posted a picture of one of their students who had made a sign to ask somebody to go to homecoming that said something like this: "You are the natural log of e for me." Because natural log of e is 1. So some of you guys are trying to, get some women out there. You might want to try this. I think that could be effective. I think it's going to work. You might not want to ask out, You might want to be selective who you're asking out for this. It's going to have to probably be somebody in this class, maybe. So, just some dating tips possibly for you there. See, like right now, there's maybe not a large number of people in the school that are going to know what that even means. But get to college with a bunch of nerds combined, this could work. It could work. Huh? I mean, I don't think he's going to go to homecoming with any of y'all, but I think he would understand it, yes. So if you yeah. So, yeah, he is going to chaperone prom. So, but you could try this. He said he refused. He traded with somebody so that he said somebody else went for him, and he's got to go to prom. Yeah. Well, actually, I think Miss Tomlin did that for him. I don't know if he realizes that she was nice enough to find him a replacement, so he didn't have to do it. But yeah. I mean, I understand why he didn't want to do that, but I also understood that he could have signed up early enough that it wasn't a problem. All right, so let's.
Darcy was walking in as I was leaving to start his rotation.
Yeah. If you, yeah. Second shift's really the way to go, though. You got to be there less time. Cleanup doesn't take very long. As long as you don't mind staying up a little bit later. All right. Number 6. So, e to the x are the easiest derivatives that you will take. Because the derivative of e to the x is e to the x. So if I have a problem like number 6, I would just have 3 e to the x. It is its own derivative. The 3 is a scalar multiple, minus 4 for that one. For number 7, my derivative, or here I've got a negative exponent. I can't do anything with that right now. So I'd have to move it up to the top, 6e to the x. And so what is the derivative of 6e to the x? It's 6e to the x. Now you do have an issue if you have e to the negative x, or if you have e to the 2x. That is actually like a different type of problem, so you shouldn't see anything that's asking you to do that right now. If you see a negative exponent, there should be a way to get rid of it before you actually take the derivative. Because the derivative of e to the negative x is not e to the negative x. It's not its own derivative. Only e to the x is its own derivative. But they should be the easiest. However, what I usually find is because it is sort of these transcendental functions are sort of like the exotic functions, the ones that are like, oh, we haven't done as much with that. We've done polynomials since we were in Math 1, but we haven't dealt with this as much. Students get tripped up on these. So, program yourself right now that e to the x is one of the easiest ones you're going to deal with for everything that you do. Logarithms are going to follow this rule. The derivative of a log base b of x is going to be 1 over x times the natural log of whatever the base was. So for example here, if I have y equals log base 5 of x, then my derivative, I could call it dy dx, I could call it y prime, either one of them is fine, is going to be 1 over x times the natural log of 5. For number 9, we've got 6 times the log base 4 of x. So that 6 is a scalar multiple. It's just going to kind of hang out front. And I'm going to have 1 over x times the natural log of 4. And they're probably not going to leave it like this. That 6 is like a 6 over 1. They're probably going to do it like this. And then we'll show you crazy evil stuff that they do sometimes. All right, so definitely free response. I mean, you could leave it here, or here's not very hard to get to either. All right, multiple choice. They're probably not going to leave it like that on multiple choice, which is one thing that makes these like almost like an evil problem, especially when they're not calculator active, because you can't check your answer choices, see if it gives you the same decimal. Sometimes on these, you'll get this answer, you've done everything right, it was pretty simple, you feel good about it, and you go and look, and the answer choice is not there. And then you're like, I know I did this right, why is the answer choice not there? It is because natural log of 4 can break down. Anybody know how to break down the natural log of 4? It has to do with properties of logs that you learn in Math 3 and well, no, you might have done them in Math 3, but definitely we did them in pre-calculus.
Well, you can't drop a log.
You cannot drop a log.
That's the only one I know.
Yeah, but I could write 4 as 2 squared. Then there was a property of logs that told us what we could do with that exponents. Anybody remember what we could do with those exponents?
Stick it out front.
It can go out front. So that means natural log of 4 is equal to 2 times the natural log of 2. And so if I change this to x times 2 natural log of 2, everything here is being multiplied together. That 6 and that 2 can reduce. So that'd be a 3, and that 2 will just go away. And you will get 3 over x natural log of 2. Now, I would never tell you to do that on free
Can't
response.
you just go ahead and reduce that beforehand, not having to do all that? It's like the 6 and the 4.
It would work on this one, but if you had something like, for example, let's say we had, let's say that we had x natural log of 8, and let's say we had 6 up here. Let's see if that would work. There's ways that won't, because that would be natural log of 8, would be natural log of 2 to the 3rd, which would be 3 natural log of 2 right there. So this would be 6 over x times 3 natural log of 2. That would reduce, you get 2. So in this case, you would have 2 over x natural log of 2. So 6 over 8 does not reduce to 2 over 2. So the fact that you could just reduce 6 over 4 and get 3 over 2 is just something that happens on this one particular example. So it would not be something that you would want to do with all problems. So. All right. Now, same rule. If we use the same rule for natural log of x, then our derivative would be 1 over x times the natural log of the base. What's the base on a natural log? E. And what did we just say natural log of e was? 1. So that's just 1 over x. So whenever you're dealing with e's and natural logs, you don't have to have that extra like natural log of something there. Or if you do, you can do it using the other rule, and you'll have natural log of e, but you just need to know that's 1, so it is going to go away. So it makes it a little bit easier for this. You gotta, if you're taking the derivative of number 10, you're going to have 4 times natural log of x. That derivative is just 1 over x, which is going to give you 4 over x. Right there. For 11, for this one, natural log of x, the derivative is 1 over x, so that's going to end up being 6 over x. And then I really should have done this first, I guess, 6 natural log of x minus, this is going to be x to the negative 2, so you'll get plus x to the negative, or I'm sorry, you get plus 2x plus 2x to the negative 3. You might see it left like this. You may see it 6 over x plus 2 over x to the 3rd. You may even see it where they get common denominators. So you could multiply by like x squared on the top and bottom here and get 6x squared plus 2 over x to the 3rd. Again, FRQ, stop as soon as you've taken the derivative. You don't have to simplify it. Multiple choice, it might look something like this. Okay, questions? All right, let's look at a couple more they're not terribly complicated, but write the equation of the line. Tangent to the graph of f of x equals 4x minus natural log of x at x equals 1. When I write the equation of a tangent line, we did that on the warm-up, what do I need? Slope, point. All right, so for the point, I'm just plugging into the original, right? So f of 1, which is going to be 4 times 1 minus natural log of 1. What is natural log of 1? Let's think about this. Natural log of 1 equals, we don't know, we'll call it x right here. We're trying to do this without a calculator because a lot of the times this stuff happens to be on a calculator inactive. If I want to get rid of a natural log, what do? E to the power, right? So 1 equals e to the x power. What's the only thing that x could equal that would give us 1? 0. So this is important for you to know. You might want to put a box around this and make sure you've got it memorized. Natural log of 1 is 0. Right? So natural log of 1 is 0, so we got 4 minus 0, which is just 4. So my point is 1, 4. The other thing we need here is the slope. To find the slope, we need the derivative. So if I make sure you label this f prime of x, because a lot of times on this you get a point for the derivative. If you don't label it, you don't get that point. So label everything so it's very clear what you're doing here. Joshua, what will I get whenever I take this derivative? Very good. And then when I plug in my 1, I want to relabel this f prime of 1. That just tells me I plugged 1 into the derivative. So we'll get 4 minus 1 over 1, which is going to give us 3. That's my slope. And so then my equation will be y equals 3 times x minus 1 plus 4. Okay. Now, one thing about AP questions, and really it's one of the reasons it's so good, like the material and stuff that they put out, is they can ask you the same question a million different ways. So if you look at the next question, it is the line y equals mx plus b is tangent to the graph of g of x at x equals 2. What are the values of m and b?
What's the slope of the...
It wants the slope and the y-intercept of the tangent line, right? We're doing the same thing here that we were doing in number 12. The only difference is it wants us to tell us the slope and the y-intercept of the tangent line, right? So you're still doing all the same process that you did on the last problem. It's just asked it a lot differently. A lot of times it throws students off. But for you to be like a really good math student, you need to be able to recognize what all of these different things are talking about, because you guys are going to go to college possibly and take other math classes, or maybe not. This could be the last one you need, but if it's not, if you do take other math classes, in college, there's a lot less standardization of how teachers teach. They got a lot more freedom on how they want to teach things, and a lot of times you've got teachers coming from all kinds of different backgrounds. A lot of times, especially in the math department, they are not from the United States. You might have a professor from India or from Russia or from who knows what, that has a lot different background. They might teach things differently. You need to be adaptable to that. Not just like, this is not how Miss Hyatt does it, I can't do it. Or Miss Hyatt didn't teach me how to do it this way, I'm never going to learn it, right? You need to be adaptable to that. And AP does a good job of doing that by asking things in so many different ways. It's painful sometimes because students are like, just tell me what you want me to do more clearly and I can do it. But it's really good for you mathematically as a math student. So this one, we just need to do g of 2. And we get 3e squared plus 2. Now, here's the problem. This is not a calculator active problem, nor is it supposed to be a calculator active problem. E is 2.718128 something, right? I don't even think that's right. I think I got that. 1828 maybe. Anyway, you're not going to be able to get a decimal approximation of that accurate to 3 decimal places that you can use for this very easily, right? So, you have to leave it like this. This drives me crazy. I hate problems like this, but they put them out there. So your point, you can't simplify that any. Your point for this is 3e squared plus 2. 3e squared plus 2 is a number. If it were calculator active, we'd type it in and get a decimal for it, but it's not. So we got to just leave it like that. Whew. Now we got to do our slope. So we got to do the derivative of this. Remember, each of the x's are the easiest derivative. Miles, what would the derivative of this be? Yeah, that's it, because the 2 will go away. It's just a constant, right? Derivative of 2 is just 0. So we just got 3e to the x. So g prime of x is 3e to the x. We've got to plug in 2. So we got 3e squared. That's our slope. Okay, now we have one answer already. What is m? Is 3e to the second, because that is our slope and m is your slope. So there's one of our answers already. Now for the second answer for that b, it's asking us for the y-intercept. So we got to write our equation, which is awful because we're going to have y equals 3e squared times x minus 2 plus 3e squared plus 2. No, I do not like this at all, but I've got to make you do it because they will ask you to do it, and then you'll be like, Miss Hyatt didn't teach me that. So I need the y-intercept. What am I going to have to do to get to the y-intercept for this? What? No. I gotta distribute. Okay, so I will get y equals 3e squared x minus 6e squared plus 3e squared plus 2. Thank you both. And if you got your warm-up and your homework, I'll take those two. And these two right here I could combine, right? So I've got y equals 3e squared x minus 3e squared plus 2. So right here, this was my m. This was the number that was multiplied by the x, right? There's my m, x. What's the b? It's ugly. Negative 3e squared plus 2. All of this stuff over here, yeah, I could make that like that. That is your plus b. And it's a number because if we type that into our calculator, it would give us a decimal for that, right? Don't you love a problem like that? The process is very simple, and if they had given us just like straight numbers, that would have been not a very difficult problem, right? But the e's make it difficult on that. All right, let's see. We're about out of time. Okay, so your assignment is going to be you guys do you have both of these last two, or did I leave that last one off? Shoot, I shouldn't have left that off. I was trying to save paper and not copy one slide for this. We may just do 4 and 5 for a warm-up in the morning. So our book does not have a lot of practice with the e's and natural logs in it right here. So I had made 5 problems to add to it, but I did not copy that last slide, so you don't have 4 and 5. So your homework is these problems right here from the book, and then do 1, 2, and 3 for me here. We'll do 4 and 5 as our warm-up tomorrow, since I didn't copy those for you guys.